Chapter 10, Probability. So basic concepts. We need to know a couple of terms about probability before we start. The result of an experiment is called the outcome. For example, the outcome of rolling a die will be 1, 2, 3, 4, 5, or 6. The outcome of tossing a coin will be heads or tail. So event is any particular outcome or group of outcomes. Simple event is an event with only one outcome, and sample space is all the possible outcomes. So here it is. So we just talk about this. So when you roll a six-sided die, what is the sample space? Sample space is all the possible outcomes. So sample space equal to, we usually use a bracket and including all the possible outcomes. In this case, 1 through 6. Now, basic probability. The probability is number of ways event can happen divided by the total number of outcomes. For example, what's the probability you will roll a 3? Is 1 out of 6. What's the probability of rolling a number larger than 4? Now, how many numbers are larger than 4? 5 and 6, 2 numbers, right? So 2 out of 6, which will reduce to 1/3. What's the probability of rolling in even numbers? The even numbers you can roll is 2, 4, and 6. There's 3 numbers. So it's 3 out of 6 total numbers. So answer is 1/2. All right. So here's another example using cards. Bucky has a deck of standard 52 cards and wants his friend Satchel to draw a card. After Satchel draw a card and he puts it back in the deck, what's the probability of him drawing an ace from the deck of 52 cards? Okay, well, now think about how many there are 52 cards total, not including Joker. That's what standard 52 card means. What a chance you get an ace? The chance of getting an ace, well, there are 4 aces in the deck, so it's 4 out of 52, which is 1/13. All right, here's another different example now involving cards or rolling a die. A survey was taken of drivers emitting or running red lights last year. The number of yes response was 500, and the number of no responses was 213. What's the probability if a person choosing a random, he or she has run a red light in last year? Now, so what we want is people who run a red light. So that's these 500 people here. These 213 says they did not, right? They don't run red lights. Okay, so it's 500. So that's the number we want on top. That's the outcome where we want. But what's the total outcome? Now the total is the people say yes to the running red light, and the people say no. Together is 713. That's how we get a 713. So the probability someone run a red light is 500 out of 713. If you take your calculator, divide this, you will get 0.7013, which is about 70%. Probability equal to 0 means it's something will never happen or impossible, and probability equal to 1 means that the event will certainly going to happen. Now remember, the most important rule for probability is probability has to be between 0 and 1. Okay, so working with events, here we go. Now the complement of events is just like the complement of sets, so that means the opposite or not, right? Okay, so for example, okay, what's the probability of someone who not drawing a queen out of a deck of 52? Well, the chance of getting a queen is 4 out of 52. What a chance you're not, in other words, complement, not getting a queen, or it will be the other 48 out of 52, right? Now remember, since everything adds up to be 100%, so you just take 1 minus the probability of getting a queen. The probability of not getting a queen, therefore, is 48 out of 52, which reduce down to 12/13. Now, probability of 2 independent events. So if you take a look at this, all right, so when you draw a card, we'll look at Satchel again. He puts put it back in the deck before drawing another card. If Satchel draws a card which is a spade, and does not replace the card, does not, okay, that's important, okay? So the question is, what are the chances he will get 2 spades? That's the question, okay? So we have 2 independent events. All right, so let's see what happens. if he put the card back every time, now the first time, what are the chances you get a spade? There are 13 spades card out of 52. Okay, that's a first card, probably the first card. Now, since you put a card back, so you're gonna start over again. And now, when they do two card draw, that means one card and another card, and we multiply in probability. Okay, any notion of the or the word and A and D, it means you multiply. So what I change, you get one spade card followed by another spade card. Now the second spade card also has a chance of 13 out of 52. But all right, so what if you do it without replacement? Okay, so if you draw a card without replacement, the chance of getting a first card is 13 out of 52. But the chance of getting a second card is, well, if you already get a first card, it's 13 out of 52. What a chance getting another spade card. Now, guys, this number is incorrect. Okay, there's a typo in here. The answer should be 12, because if you kept one card and you didn't put it back, you now only have 12 cards out of total of 51 cards now left in the deck. So with 13 out of 52, that's the first the chance of getting the first spade card, and the second card is now only 12 left. That should be 12 over 51 card because you kept one spade card. So in these two events, okay, so the first event we call it independent, the second event we call it dependent, because the first event, the two spades are independent from each other. No matter what happened, the first event does not affect the second one. Versus the second one, if you don't put it back, okay, you kept the card. Now the second event depends on what happened in the first event. Since you already have a spade card, the chance of getting another spade card is totally different now because you kept it. So these two events are dependent because the second event depends on what happened in the first event. Okay. So here we go. So independent versus dependent event. So let's do another one. What's the probability he draws a heart, replace the card, and then a spade? Okay. Well, if you draw a heart, what are the chances of getting a heart? 13 out of 52. And multiply a spade. Well, there's still 13 out of 52. These two events are independent because you replace the card. Every time you draw a card, you replace it back, you kind of start over again. So the probability basically is a heart times the spade. You don't have to worry about, it's not dependent, so you don't have to worry about how many cards are left in the deck because it starts over. So you multiply and reduce, you get 1/16. Okay, same thing here. In a drawer, there are 10 pair of socks, 6 white, 7 t-shirt, and 3 of which are white. Okay, so what's the probability of randomly select a white pair of socks and a white t-shirt? Okay, so these are independent, okay, because you getting one doesn't affect the other one. So the chance of getting a white sock is 6 out of 10, right? And multiply, what are the chances you get a white shirt? 3 out of 7. So all you have to do is multiply together, because getting a sock and getting a t-shirt is independent from each other. When it's independent events, all you have to do is multiply the probability of each, then you get your final probability. Okay, now if it's dependent event, this is a formula. Okay, so let's take a look at this one. Now this is actually OR. Now notice, OR you add. Unlike the event before, it's and you multiply. Okay, so let's take a look at this one. We're using Setro again, right? So you have 52 cards, and one he's going to draw only one card. All right, anything before this section here is drawing 2 cards. What are the chances you draw 2 cards in a row? So you want something and something. This one is you just want to draw 1 card, but you want to say what's the probability you will draw, let's say draw a queen. That's an easy one, 4 out of 52, right? Now, what's the probability you will draw a spade, which is 1/4. 13 spade out of 52. But what's the probability of spade or heart? There we go, or. So you only still getting only 1 card. You just want to see what the chance getting that 1 card is a spade or a heart. Well, chance of getting a spade is 13 out of 52. And plus, or means plus. Okay, and then our chance of getting a heart is 13 out of 52. So together is 26 out of 52, so it's 1/2. Now, compare this one. I want you to compare C and D. What's the probability of getting a queen or a spade? Now, spade or a heart, the thing about spade or heart, they don't overlap. Okay, so when you talk about or this is called addition rule, you need to think about, will two events overlap or not? Are they, we call it mutually exclusive or not mutually exclusive. All right, for event C, where spade and heart, there's no one card that spade and heart at the same time, so they are not affecting each other. So we call the event in C mutually exclusive. Now in D, it's not mutually exclusive because whatever chance you get a queen or a spade. So figure out all the possible getting a queen, which is 4 out of 52, and you want to get a chance of getting a spade, which is 13 out of 52. But we double counted the card because there's one card that's is a queen of spade that you kind of hear. You also kind of hear again. So you have to subtract the chance of them happening at the same time, which is the one card. So to be careful with that, you need to add them up and subtract the overlapping. And this is where the example right here, it says probability A and B. We need to subtract that. Okay. So what are the chances you getting a queen and a spade at the same time? That's one card. Versus spade and heart, there's 0 card that's in the category. That's why you don't subtract anything. Or you subtract 0, so it doesn't show up. All right, so you need to be careful with these two events. When you talk about or, you have to consider, are two events mutually exclusive? That means they don't overlap at all. Or they're not mutually exclusive. If they are not mutually exclusive, you need to subtract their what they have. In other words, intersect. Thinking of the sets. What are the queen and spade intersect? There's only one member in there, right? Queen of spade. Okay, now the probability of at least one. Now, whenever I ask you the probability of at least one means the opposite or complement of none. At least one means opposite of none, right? Okay, so whenever you see the probability of at least one is equal to 1 minus probability of none, because everything's out 100%. It's a complement. Okay, so we use a formula, right? Okay, we want to find a probability of a number that is at least 5. Okay, well, at least 5 means what? 1 minus probability of what's the opposite of that? Less than 5, right? So how many numbers are less than 5 if it's out of 100? 4 out of 100, right? Okay, so here's another one. This is one probably more similar to what's on the homework of your test. Okay, so it reads, in a drawer there are 10 pairs of socks again, 6 white, 7 shirts, 3 of them white. If a pair of socks and the teacher is randomly selected, what's the probability at least one of them is white? So it could at least one. That means it could be, one sock is white, or one t-shirt is white, or both, right? But the only scenario is none of them are white, right? If you could get both of the sock and shirt that's not white, then that's not what you want. So we do 1 minus. So what's the probability of none of them are white? Well, out of the 10 pair of socks, 6 of them are white. So that means 4 is not white. Out of the 7 t-shirts, 3 of them are white. That means 4 is not white. So let's multiply all the not white possibilities, 16 out of 70. Then 1 minus that will be at least one of them is white. So 1 minus 54 out of 70. The answer is 27 over 35. Actually, I'm sorry, there's a typo again here, right? The answer should be 54. There's no 1 here. The answer is 54 out of 70, and which reduced to 27 out of 35. There shouldn't be a 1 here. So, guys, when you read your answers, okay, in the My Open Math, if there's typo, okay, don't worry about it. That's why I made these videos to kind of help you out with that. Okay, now we're going to begin with this slide on the next video, where we can sometimes your data is giving you in a contingency table, and if that's the case, well, let's explore how we find the probability of certain event that we're looking for.